Hello, I'm Alex and this is my channel, Finally Functional. This video is part of a series where I am making a motorized shoe slash platform to be used with virtual reality games. So you would put your foot on the top of the platform like this, and as you take steps forward, the shoe would bring you back. In this video, I show how I built this and the testing I did for it. You can see I took it apart a little bit so that you can see how it works. Here's the gearbox. When the motor turns, it turns these omni-directional wheels that I designed. And there's wheels in two different directions so that you can go side to side and forward and back, or diagonals, any direction you want. So when you're playing the game, you can walk in any direction, or you can strafe, you can do whatever you want, and the shoes will just keep bringing you back towards your origin point.
Arguably, the most important part of the design are the omnidirectional wheels. They are only 2 inches in diameter, and each wheel has 24 3mm bearings to ensure that they can roll very nicely even under a heavy load. Each roller is split up into 3 parts in a way that minimizes gaps in the perimeter of the wheel so that when the wheel rolls, it is smooth and doesn't have bumps. The wheels are coupled to the motor via the gearbox shown here. The gearbox has a 2.25 to 1 gearing ratio and uses a 230 kV flip sky motor meant for an electric skateboard, so it should be overpowered for this application. The gears have covers that will keep dust and debris out of the gears.
Okay, I showed you this half. Now here's the other half with a drive that's very similar. The axle's just a bit longer, and now the two halves just slide together like this and screw together. Now the platform along with the two drives are put together. You can see there's at least one wheel in each corner. This one here is just an idler. Then if we look at the top, there's this metal bar going across to make the platform stronger. To help keep the wires organized, I'm using a little trick that I learned when I put together my 3D printers. You can see I have these wires here, and there's a zip tie. I can put the wires in between and then tighten down the zip tie. And the way this zip tie is, it looks like it's embedded into the platform. The way that works is that there's these two holes here, and they're actually connected so that if you put a zip tie through on one end, it'll come out the other, as you can see here. Then I just run the wires through and tighten them down, and it keeps the wires organized. I got the wires zip tied down, as you can see, and then here's the box on the side for the electronics. There's two VEX and an Arduino there, and then the battery up there. And there we go, it's put together. There's a little bit of a gap here caused by the wires on the side. I'm just gonna trim this down a little bit, but it's fine for now, and I'm gonna start testing.
I started off my testing with just putting a small amount of my weight on the shoe. You can see here that I'm leaning away from the shoe. It seemed to work fine, so after that I tried putting more of my weight on the shoe. I found that when I put my full weight on the shoe, the gears would start skipping. I also found that some of the roller pieces came off during testing. The rollers are coupled to the bearings with glue, and for many of the rollers I only used a couple dabs of glue. I'm going to reattach them with glue around the entire perimeter of the bearing to see if that holds.
So I took a couple of the rollers off of the wheels, as you can see here, and I have them here in front of me. One here and one here. This one I re-glued, this one I didn't, and it's actually very easy to take the roller off of the bearing here. I just didn't use enough glue. Like I said, I only did like a dab, and that's it. For this one, I went around the whole perimeter and on the side a bit, and now it's, at least, but I can't get it to come apart, so I think I just need to re-glue a bunch of these and it'll be strong enough. So these teeth can still come apart a bit to cause the skipping. I think it's because this bolt and this rod, this axle, they can flex a little bit. They can come apart under the stress. So I'm going to reinforce this side the same way I reinforced this side. On this side, the axle and the bolt here, they cannot come apart at all because this 1/4 of an inch piece is holding everything together. So I'm going to do the same on this side so that these cannot flex apart at all. Adding more reinforcement on this side, the same as this side, it will cause this whole thing to be a little bit longer. So on here, I'm going to have to make the platform a little bit wider because I'm going to need a little bit more space right here for that extra reinforcement. So I'm going to redesign this gearbox to eliminate any kind of play between the gears, any wiggle room for the gears to come apart. And then we'll retest this and we'll see how it goes. If you liked the video, be sure to leave a like and subscribe if you want to see more. Leave a comment. Tell me what you think. See you guys next time.